Hello guys, and welcome once more to this new video on my YouTube channel, where actually we are going to be solving the Cameroon GC examination pure mathematics mechanics paper 3 June 2022 question 8 actually. So this question was divided into two parts, that is question 8 Romans 1 and question 8 Romans 2 actually. Question 8 Romans 1 reads, two events A and B are such that P of A equals 3 divided by 5, P of A union B equals 7 divided by 10, and P of A intersection B prime is equals to 3 divided by 10 actually. Find P of B. Question 8 Romans 2 reads, at lunchtime, a man chose at random from three restaurants X, Y, or Z to have lunch with probabilities 0.5, 0.1, and 0.4 respectively. His choice will be ready at X, Y, and Z for lunch L with probabilities 0.25, 0.3, and 0.2 respectively. Find the probability that A, the man will have lunch, B, the man will not have lunch, and C, Y is chosen given that the man will have lunch. Let us actually move into the solution of this question. So we are going to start by solving question 8 Romans 1 actually. So in question 8 Romans 1, we are being told that we have two events A and B, which are such that P of A equals 3 divided by 5, P of A union B is equals to 7 divided by 10, and P of A intersection B prime is equals to 3 divided by 10. We are being asked to find P of B actually. So to find P of B, we are going to use this relation, which says that what? P of A union B is equals to P of A plus P of B, then minus P of A intersection B, from which we can come out that we can deduce the value of P of B. That is, P of B is going to be equals to P of A intersection B, then plus P of A union B minus P of A actually. We have simply made P of B the subject of the formula here, in order for us to obtain this actually. So remember, we already have P of A union B, we have P of A union B, we have P of A, but we don't have P of A intersection B. How can we therefore obtain P of A intersection B? We are being told that we have P of A intersection B prime to be equal to 3 divided by 10. We have to make this very important recall, which says that what? P of A intersection B prime is simply equals to P of A minus P of A intersection B, from which we can therefore deduce the value of P of A intersection B to be actually equals to what? P of A actually, then minus P of A intersection B prime, from which we have already obtained the value of P of A intersection B. So having already P of A union B, P of A, and then P of A intersection B, which is actually what? Which is actually P of A minus P of A intersection B prime, we can therefore obtain the value of P of B simply. Yes. So putting back the value of P of A intersection B, we are going to have what? P of B to be equals to P of A minus P of A intersection B prime, which is simply what? Which is simply which is simply P of A intersection B, then plus P of A union B, then minus P of A simply. We can clearly see that this P of A is going to cancel with this other P of A actually, yes, and we are going to be left with P of B, which is going to be equals to P of A union B, then minus P of A intersection B prime, and we have P of A union B, which is what? 7 divided by 10, and we also have P of A intersection B prime, which is actually 3 divided by 10. So substituting those values, we are going to obtain P of B to be equals to 7 divided by 10, then minus 3 divided by 10, from which further simplifying, we are going to obtain P of B to be equals to fit, which is actually what is being asked for us actually to find in the Romans 1, that is question 8 Romans 1 actually, yes. Let us move into the next part actually of the question, that is question 8 Romans 2. Question 8 Romans 2 reads, at lunchtime, a man chose at random from 3 restaurants X, Y, or Z to have lunch with probabilities 0.5, 0.1, and 0.4 respectively. His choice will be ready at X, Y, and Z for lunch capital L with probabilities 0.25, 0.3, and 0.2 respectively. So the A part of the question is asking us to find, okay, the probability that the man will have lunch. B part of the question asks us to find the probability that the man will not have lunch, and the C part of the question actually is asking us to find the probability that Y is chosen given that the man will have lunch actually. So the first thing which you have to do here is actually to first of all represent this information on what we call a tree diagram, on a probability tree diagram. So representing this information on a probability tree diagram will enable us actually to answer, okay, those questions more easily actually. Yes, so representing in first place this information on a probability tree diagram will facilitate or will help us actually to answer easily those questions properly. So in the first place, representing the following information on a tree diagram, on a probability tree diagram actually, what are we going to have? Simply, we have been told that we have a man, okay, a man who wants to have lunch actually, and there are 3 restaurants which are proposed to him, that is X, Y, and Z. So the probability that the man goes into restaurant X actually is given to us to be 0.5. okay, the probability that the man goes to restaurant Y is 0.1 actually, and the probability that the man goes to restaurant Z actually is 0.4 actually. So these are the different probabilities that the man, okay, can go into the different restaurants actually to have lunch. Of course, yes. So that's what this first sentence actually explaining. That is, take it back again. I will take it back again. That is, the probability of the man, okay, to go to restaurant X, okay, and desire to have lunch is actually 0.5. The probability that the man, okay, will go to restaurant Y, okay, and probably get a lunch there is 0.1. And the probability that the man, okay, can also go to restaurant Z actually, okay, to have his lunch there, okay, if it is the case, it's actually 0.4 actually. Yes, so this is what actually, okay, is being explained in this first sentence actually. Then we have been told that his choice will be ready at X, Y, and Z for lunch with probabilities 0.25, 0.3, and 0.2 respectively. What does it mean? It means that if, okay, the man, okay, goes to restaurant X to have his lunch, okay, he is going to obtain a given order, okay, events here actually. Similarly for Y and Z, so representing them, we are going to obtain this actually. That is, the probability that the man, okay, will go to restaurant X actually and then have lunch there, because the lunch, we have been told that the lunch will be ready at X, okay. The probability that the lunch will be ready at X is actually 0.25 actually, which is what we have represented here. And similarly, the probability that the lunch will be ready at restaurant Y is 0.3, and the probability that the lunch will be ready at restaurant Z is actually 0.2. okay, yes, as we indicated as such actually. Then the next which we have to know, which we need to do actually in order for us to complete this tree diagram, is very easy. That is, there can also be a situation where, since we are in probability, okay, there can also be a situation where actually the man does not have lunch, okay, that is, the lunch is not ready in restaurant X. The lunch is not ready, the probability that the lunch is not ready in restaurant Y, and the probability that the lunch is not ready in restaurant Z. Actually, we have also to consider those situations, okay, because here we are dealing about probability that we are not often sure, okay, of all the cases actually. Yes, so the probability that, okay, the man will not, of course, have, that is the probability that the man, okay, will not have lunch actually in restaurant X, that is the probability that the lunch is not going to be ready in restaurant X is 0.75. The probability that the lunch is not going to be ready in restaurant L is in restaurant Y actually is 0.7, and the probability that the lunch is not going to be ready in restaurant Z is actually 0.8. How do I actually get these values? By simply doing what? See, we know the sum of the probability gives us 1 actually. So in order for us to get this negation actually, okay, that is this negation, that is the L prime, we simply do 1 minus this 0.5 in order for us to get the probability that the lunch is not going to be ready in restaurant X. That is 1 minus 0.25, we get 0.75. And similarly for Y and Z, that is the probability that the lunch is not going to be ready, okay, in restaurant Y is simply going to be 1 minus 0.3, will give us 0.7. And Finally, the probability that the lunch is not going to be ready in restaurant Z is simply going to be 1 minus 0.2, or actually 0.8 actually here. So we are going to represent actually the scenario, okay, of what is actually happening globally, okay, yes, or concerning actually this question. Actually, we can then answer the questions freely, that is the A part, the B part, and the C part of the questions more easily and freely actually, yes. So answering in the first place the A part of the question, that is asking us to find the probability that the man will have lunch. So the probability that the man will have lunch is simply going to be P of L. Actually, the probability that the man is going to have lunch is going to be what? In order for the man to have lunch, okay, the man can either have lunch, okay, from restaurant X, or the man can either have lunch from restaurant Y, or the man can either have lunch in restaurant Z. Actually, that is the probability that the man will have lunch will simply be the probability that the man can have lunch in restaurant L, in restaurant X, that is P of X intersection L, this situation like this, plus the probability that is, you have to know that this is or plus. When in probability when you put plus, it implies or actually, yes, or the probability that the man, okay, will have lunch in restaurant Y, which is actually P of Y, okay, then intersection L, then plus the probability that the man, okay, will have lunch, okay, or in restaurant Z, actually it's actually P of Z intersection L actually. So what is then P of X intersection L, P of Y intersection L, and P of Z intersection L? It is simply what? P of X intersection L will be the product of this, that is 0.5 and 0.25, in order for us to get the P of X intersection L. P of Y intersection L is going to be the product between 0.1 and 0.3, and P of Z intersection L, okay, is going to be the product of 0.4 and 0.2 actually. So writing it all, we are going to have P of L, that's the probability that the man will have lunch, to be equal to 0.5, then times 0.25, then plus 0.1 times 0.3, then plus 0.4 times 0.2 actually. Doing that, we are going to obtain the probability that the man will have lunch to be 0.125, then plus 0.03 plus 0.08 actually, for which you get P of L to be 0.235. This is actually the required probability that the man will actually have lunch actually, yes. So this probability is simply the probability that the man will have lunch actually, yes. The part of the question asks us to find the probability that the man, okay, will not have lunch. To do this, what are we simply going to do here? We are simply going to write after the negation of this statement, that is P of L prime simply, which is actually 1 minus P of L, from which we get the probability that the man will not have lunch simply, from which we are going to obtain P of L prime, okay, to be equal to 1 minus P of L, which is 0.235, from which we therefore obtain P of L prime to be 0.765, which is actually the required probability that the man will not have lunch actually, yes. And the simple question asks us to find the probability Y is chosen given that the man will have lunch. This is actually a conditional probability actually, yes. So we are working here on conditions in the simple question. We have been told that find the probability that Y is chosen given that the man will have lunch. That in the first place, we already know that the man will have lunch actually, and we have been asked to find the probability that Y is chosen. So knowing that the man will obviously have lunch, okay, we have been asked to find the probability Y actually will be chosen. This is actually a conditional probability. To do that, we are simply going to have what? P of Y, okay, that is P of Y, okay, given that L have already occurred actually. Yes, this is what it means actually. That is conditional probability. The probability Y is chosen given that L, that is the man have already have lunch, that is the probability that Y, okay, occurs given that L have already occurred, that is the man, okay, will actually have lunch actually, yes. So P of Y, okay, bar L is equal to P of Y intersection L, then divided by P of L actually, yes. What is P of Y, okay, intersection L actually? It is simply what? It is simply this 0.1 then times 0.3 actually, that is P of Y, okay, that is the probability that the man, okay, will have lunch, okay, the probability that the lunch is going to be ready in restaurant Y actually. That's the probability that the man will actually have his lunch in restaurant Y actually, which is P of Y intersection L, which is actually the product of 0.1 and 0.3. Then divided by P of L, that is the probability that the man will actually have lunch, which we calculated previously to be 0.235 actually. From which we therefore get the result actually to be, that is the probability that Y is chosen given that the man will have lunch is going to be actually 0.128 actually, which is actually what is being asked for us actually to answer in this question actually. Yes, so this question of probability actually, it is not too difficult, it is quite very direct. But the thing is that the first thing you have to understand here is that most of the times, if there are some questions, okay, which you can easily come out with your tree diagram, your probability tree diagram, as I did here actually, it will be very easy your work once you are going to be answering questions, okay, concerning these probability stuffs. Once you have a situation like this, try to see whether you can come out with your probability tree diagram. If it is the case, then come out with it. Once you are going to have a probability tree diagram, it's going to be more easy for you actually to answer any questions which are going to come just below actually. Yes, more easily. Yes, so we have come to the end actually of this video. Okay, yeah, so thank you very much for watching. Okay, then remain tuned, okay, for a very next interesting video concerning mechanics. And of course, happy new year to each and every one of you, and Merry Christmas. Thank you, and see you